it's worth taking just a short moment to remind ourselves what these trigonomic identities look like when you plot them as functions of theta, or angular position on the circle. Now remember that cosine is a measure of the horizontal position with respect to the center of the circle. So at time equals 0 and at position theta is equal to 0, we're sort of at the largest it could possibly be. It's the most positive horizontal displacement, assuming that the positive side is to the right of the center of the circle. All right, so we start out at a maximum, at a positive maximum. And as time goes on, as we start to move around the circle, that horizontal displacement is going to get shorter as we move to a more vertical position. And as we get all the way up to pi over 2 radians, or 90 degrees, we can see that we have 0 horizontal displacement at all. So we've moved from a positive maximum to 0. And as we start to move left to the center of the circle, we could describe this as having a negative horizontal displacement. So on our cosine plot, we start to move into the realm of negative values. And we eventually move to 180 degrees, or pi radians, where we have our most negative value possible. And as we cycle back up, we'll reach another 0 displacement at negative 90 degrees, or 270 degrees, or 3 pi over 2 radians, and we'll eventually return to our starting point. And so a periodic function that will repeat as you move around the circle more than once. Okay, on to sine. All right. Sine is a measure of the vertical displacement. So at angle 0, or at this starting angle, we have no vertical displacement at all. So our function is our plotted function is starting at 0. And as we start to move around the circle, it's going to become a positive number and eventually reach a positive extreme when we're at pi over 2 radians. And as we continue moving around the circle, it's going to return back down to 0 vertical displacement at pi radians, or 180 degrees. And then we're going to move into the negative realm and eventually reach our negative extreme. And then back to the starting point. So unlike our cosine function, our sine function will start with a value of 0 and increase in the positive direction as you start to move around the circle. The cosine function starts at an extreme and decreases initially as you start to move around the circle. But otherwise, the sine and the cosine functions, plotted functions, are pretty similar. Their periods are exactly the same. Their amplitudes are exactly the same. It's almost as if they're the same function, just shifted 90 degrees from one another. And then the tangent function, which we don't need to spend a whole lot of time on, gets really funky because, remember, it's the ratio of the vertical displacement divided by the horizontal displacement. So initially, since there is no vertical displacement, we start out at 0. And as we move around the circle, we start to get a very large vertical displacement and a very small horizontal displacement, which means we're going to approach infinity as we get to pi over 2 radians. And then we sort of have to start over in the negative infinity realm, where we have a very large vertical displacement and a very small negative horizontal displacement. And as we get back down to where we have no vertical displacement at all, we're back towards 0. And where we have both negative vertical and negative horizontal displacements, we enter the realm of positive values once again. So we move very strongly in the positive direction of the plot on the bottom side of the screen, and we move towards infinity again as we end up with a very large negative vertical displacement and a very small negative horizontal displacement. All right, so I think you guys get the idea here.